Welcome to an example in which we look at a word problem and decide what kind of division it really is. Let's see it. So Bria made 90 ounces of Jell-O and wanted to put the Jell-O into 6-ounce containers. How many containers can she fill? So you understand the game plan here. Bria has 90 ounces of Jell-O. And she's going to have a bunch of containers, and they all contain 6 ounces. How many containers? Okay, so first off, it is a division question, isn't it? As it says right here, what division problem do you need to do to find the answer? What's the division problem? We need to take 90 and divide it by 6, right? So do you sense that as you read those words, does division seem natural to you? I hope so. You're taking the 90 ounces and dividing it into a bunch of 6-ounce containers, right? A bunch of 6-ounce containers. So there's two ways. Well, what this section is mainly about is thinking about division in two different ways. The two ways are listed right here. Partitioning into equal subsets and repeated subtraction. Now this is going to be kind of tricky because the difference is pretty subtle. It's pretty small. There's not a big difference, but there is a little difference, and with enough practice you can tell which one it is. So let me help you with it. When we think about taking our 90 ounces and breaking it into 6 ounces, 6 ounces, 6 ounces, 6 ounces, what are we doing? Are we partitioning into equal subsets? Well, yes, of course we are. Are we repeatedly subtracting Jell-O from the main thing? Well, yes, of course we are. We're really doing both of those. That's what's tricky about this. The difference is subtle. You're really doing both of those, but which one are you mainly doing? Let me ask you this. When you start with that 90 ounces, what's the first thing you're going to do? Pour 6 ounces into that container. What did you just do? Repeated subtraction. Then you're going to pour 6 ounces here and then pour 6 ounces there, etc. Pouring 6 ounces. You're repeatedly subtracting. That's the main thing we're doing on this one, is repeated subtraction. We're repeatedly taking away 6 ounces from the original 90. Yes, we are making a bunch of same size little sets, but we didn't mainly come in here and go, okay, what I want to do is make a bunch of little sets. We mainly thought, I'm going to pour out 6. Like, no, you might wonder, well, how would you know the difference? We did, Mr. We did make, a bunch of. Yeah, but if they had said you have 90 ounces and you want to make 10 glasses, 10 cups or whatever, 10 glasses of Jell-O. Now that's mainly telling you how many sets, right? That's the number of sets. That would be breaking into sets, mainly. You see, if they give you the number of sets right away, then that's mainly thinking about breaking into sets. But that's not what they did. They didn't give us we don't even know how many glasses this is going to take until we finish the problem. They just said put 6 ounces in each one, which is how much you're going to take out, which is how much you're going to subtract, right? So the main thing they're telling us is how much we're going to subtract. So this is mainly thinking about division as repeated subtraction. It's close though. It's subtle. So be careful. So ask yourself, is this other number, is it how many sets? Is it the number of sets or the amount subtracted? Which one is it? It's the amount subtracted, right? There's not 6 sets. There's not 6 cups. That's the amount subtracted from the whole, right? So if they give you the number of sets, then they're mainly doing the set way of thinking about division. If they give you the amount subtracted, then they're mainly thinking about repeated subtraction. Division is both things, but which one are they emphasizing? Okay, let's move on. Draw a picture using the correct diagram. I did. Then write the multiplication. Like what multiplication problem are we really seeing here? What's the answer? If you do this on your calculator, and that's fine, you can use your calculator for homework, tests, everything, get a 6, right? 90 divided by 6 is 15. You get a 15, right? So that means what times what is really being shown here? Well, it's really 6 times 15, right? A division problem implies a multiplication problem backwards, doesn't it? So 90 divided by 6 equals 15 means 6 times 15 equals what? What's the answer? 90. Oh, I'm sorry. That's not the answer. The answer was 15, wasn't it? 15 is the answer to this question, to this division. What is the answer to the division problem? It's 15. In other words, there's going to be 15 containers, each containing 6 ounces, to disperse the whole 90 ounces. So what did we do there? We thought deeply about division. So to help you, again, become a master to teach younger folks how to think about division in a word problem, we saw 90 ounces, and the 6 was the amount we were subtracting every time. So it was repeated subtraction mainly. We know the answer to 90 divided by 6 is 15, and that implies a multiplication problem of 6 times 15. A division problem always implies backwards a multiplication problem, and the answer is 15, because there's 15 containers when we're done. How many containers can she fill? That's the question. 15 containers.